So in this video we will be talking about three things. Okay, isomerism, functional groups and homologous series. Okay, so these three things we will clear in this video. So first let us study about isomerism, the concept called isomerism. So I will draw two structures here. Okay, these are the two structures I have drawn. Now you observe. Now you tell me how many carbon atoms are present in the first structure. Okay, so you count the number of carbon atoms. Yes, there is 4 carbon atoms. So C4 I can write. Okay, now count the number of hydrogen atom in the first structure. You will see that there is 10 hydrogens. So I can write here C4H10. Fine. Now come to the second structure. How many carbon atoms are there in this structure? Yes, there is 4 structure. There is 4 carbon atoms. So C4 I can write. Now how many hydrogen atoms are there in the second structure? Hydrogen atoms there is 10. Okay, so you can just count 1 2 3 4 5 6 7 8 9 10. Okay, C4H10. So isomerism means compounds having same formula but different chemical properties. So that chemical properties, so difference in chemical properties is because of its different structure or different attachment or bonding in that particular structure. So here these two are isomers. Okay, these two are example of isomers. So I will write the definition for isomerism. So now read this. Compounds having same molecular formula but different chemical and physical properties are called isomers. So if you observe these two structures will have different chemical properties because they have different structure. Okay, different type of bonding. So also we can also say the spatial arrangement of these compounds are different. Because of that, their chemical and physical properties are different. Okay, so they are called isomers, and this phenomenon is called isomerism. This phenomenon is called isomerism. So in 10th grade we are only studying about one type of isomerism. Okay, so that one type of isomerism is structural isomerism. So we are only studying about structural isomerism in our 10th grade. So structural isomerism is nothing but you can write compounds having same molecular formula but different structures. Okay, different structures, they are called structural isomers. So I will write the definition here. Okay, so this is it. So the above one that I have given is an example of structural isomerism. So C4H10. Okay, so the compound name is butane. Okay, if you don't know to name the compounds, you can check the previous videos. Okay, we have discussed, or the upcoming videos. So this is a butane, this is also a butane. So these are isomers of butane. Okay, we can say like that. So these both are isomers of butane. Okay, so that is all about isomerism. So we can give one more example and we can try to do. So we can take another example and draw its isomers. We can draw its structural isomers. So here I am going to take the compound pentane. Okay, C5H12. So I want to draw the isomers of the C4H10. So only structural isomers we have to draw. Structural isomers. So you need to understand what is meant by the structural isomers, or how can you draw the structural isomers. Just understand it is it is related with the attachment of this carbon. Okay, so I will just highlight it. So if you look at the attachment of carbon is a straight chain here. So but if you look at here, it is like a different way. Okay, so the attachment of carbon atoms, that really defines these structural isomers. Okay, again I am stressing on the point, this is for structural isomers, the way in which carbon atoms are bonded together. Okay, so if you come down to pentane, okay, one isomer, it's very easy to draw. Okay, all of you should draw this isomer if it is asked in your question paper. So what is that isomer? Nothing but a straight chain isomer. Okay, so this is an isomer. We just need to fill the hydrogen atoms. Okay, the formula states that there is 12 hydrogen atom. So attach the hydrogen atoms with the carbons. So if you are wondering how I am attaching a particular number of hydrogens to a carbon atom, then understand it, each carbon will have only 4 bonds. Okay, please note that point. Each carbon will only have 4 bonds. Okay, so the first carbon, this is already attached to one carbon atom, so I need to give only 3 more hydrogen to it. Okay, did you get it? But if you look at the second carbon, it is attached to one carbon here and one carbon here. So 2 bonds are already present. I only want to give 2 more hydrogen. Okay, that is how we do it. Now the second isomer, what I can do is, I need to change the attachment of carbon. What I can say, I can take the 5th carbon and I can attach it here. It's fine, right? I got an isomer. Okay, so just fill the hydrogens. So this will be a second isomer. I only want to attach one hydrogen to this carbon because it is already having 3 bonds. Okay, that is why. Now I will attach other hydrogens. Okay, I got one isomer. Now the third isomer. So the third isomer I want to draw is, so I am actually drawing structural isomers. Okay, so please keep that in mind. So I only wanted to change the attachment of carbons in a different way. So what I can do, I can take, okay, this, imagine I have this straight chain. I will take this 2 carbon and I will attach it here like this. Then I will get an entirely different compound. Okay, so if I fill the hydrogens, it will be exactly 12 hydrogens. The center carbon doesn't require any attachment of hydrogen because it is already bonded. Okay, now these are the isomers of C5H12. Now you will have a doubt. Of course you will have a doubt. So you can think like this, why can't this be also an isomer like this? C. Here I have attached it here, right? So you can think like, why can't I attach it here? So you need to understand both these are same. Okay, both these are same. If we are writing the name of these 2 compound, both the name will be same because the attachment is coming to the second carbon. Okay, that is why both are same. Or if you are ever wondering, why can't I do it like this? Okay, so why can't I attach it here? You need to understand these 3 are same molecule. Okay, we only just flipped it. Okay, these are all same. Even if it is coming here, so imagine this is coming here, again it is the same molecule. These 3 are same. Okay, so that is why only 3 isomers are possible for this C5H12. Okay, fine. So that is it about isomers. Okay, so if you have any doubt, you just comment below, or if you want any further explanation also, you just comment below. Okay, now let us move on to what functional groups. Okay, so since the video is getting lengthy, so I will stop this video and I will take a new video for functional group and another video for homologous series. Okay, so this is isomerism. So if you have any doubt, just comment below.